Okay, so we would have a lesson now. Day 6. All of you here, just not enough people. 17. Now I'd like to double check the attendance. 陳偉豪、趙家明。陳偉豪、趙家明 ，Are you here？
喺度。
You are 趙家明。How about 陳偉豪again？ 陳偉豪。I'll just go back to bed again. Or it's not second or third time, right? So many times. Maybe I need to invite him.
我啱 call 咗佢啦，佢應該入緊。
又瞓緊覺啊！想死啊！佢真係想係咪好掛住我啫？而家問下查我先。陳偉豪，陳偉豪。
Hello。
喂，做咩？又掛住我啊！而家又係特登做啲嘢攞我注意喎，即係唔買人哋啲朋友仔唔買你得繼續瞓喎又。喂，你近排嗰啲嘢你有冇做㗎？有冇交功課啊你？
有做下 MC 啦。
咩做下 MC 啦咁樣？做乜咁輕佻啊你真係？
冇啊，可能啱啱瞓醒。
瞓醒，快啲洗個面，快啲洗個面，我俾3分鐘你，快啲洗個面，跟住再坐翻喺度。梁善維
喺度。
你同喺度啦。李振傑
喺度。
係吳正豪、徐家榮。吳正豪、徐家榮。
喺度。
你係聽唔到你？吳正豪跟住徐家榮。唔見胡嘉倫、粵斌。
喺度。
係翁正南、陳俊熙。
喺度。
係好。跟住蔡俊明、朱俊輝。蔡俊明喺邊度？蔡俊明又唔喺度啊？ 亂晒坑啊！佢哋真係啲生活作息，交晒 SBA 未啊？你哋係咪交晒㗎啦？黎運正、李健朗
喺度啊，Sir 喺度。
係李健朗喺度，盧少華、吳文希
喺度。
盧少華喺度，係兩個都喺度啦，好啊。温志偉、余子豪、袁天佑
喺度。
係温志偉喺度，袁天佑喺度，余子豪咧係咪啦
喺度啊，Sir。
？OK，好。喂，做晒未啊？你哋係咪交完 SBA 㗎啦？請問？
唔係啊，中英文都未搞啊，未搞晒咯。
未搞晒？係。咁點算啊？
report 英文係做嗰、個presentation 咯。
係，即係要趕住見人係咪啊？係咪復課？即係一面對面上堂就要又要拎出嚟錄係咪咁啊？
係啊，應該係咁噶啦。
咁啊，所以就大家喺度衝啦！呢個禮拜亂晒龍嘅真係。
講我個老師，即係我哋
蔡俊明咧？蔡俊明喺度，又唔喺度。好。So we start from today is a calculations lesson, right? You need to go MoCal. So you have received exercise, right? A 20-mark questions. You may see it just like last time. Have you all received it? So it's time to do that exercise. Well, Cam 2 first of all, and then go back to Cam 1. Cam 2 and Cam 1. All right. Okay, you see the page. Okay, so today we are going to have a quantitative analysis. So quantitative 定量 okay, to tell you how much amount it is. So that's why you have to do MoCal. We have got two types of titration in which I would like to draw attention. The first one is redox titration. While it involves something about permanganate and iodine. So you will know it in the exercise. And second one is on precipitation titration. So I know some of you started to try to sort by topic practice. So I would like to remind you, it is on question 3 in paper 2. So you know it is analytical chemistry. Not all 20-mark questions will involve asking you titration. So spot it, it is in B part or C part. So you may see that calculations just continue, and each time it comprises 5 to 7 marks. Okay, depending the proportion when you compare with the other if the other topics. So this one should be noted, and you have to get used to this. And before you can attempt this part, you should get to know something like MoCal. Okay, you should know something like MoCal. You should know something about redox, because we are going to, very often we are asking you for the balancing the equation. And if the equation has not been balanced, you cannot proceed to the calculations. So if you want to score that 4, at least you need that 2. While we come back, we would have the practical. Okay, we are going to do some experiment work. While you will squeeze, I will squeeze some time on the supplementary lesson so that all of you know. Okay, so I will post a after-school supplementary lessons soon, such that all of you can follow. It's for Unit 55, quantitative analysis of that. So to start with, we try to do the first one, precipitation titration, because it is rather easy to follow. So precipitation titration, which is on the last question. Take a look. This is somewhat very rather easy. So you may start from here. Now, in the precipitation titration, to determine the concentration of chloride ion in the seawater, 0.500 mole per dm cube silver nitrate is used to titrate against 25.0 cm cube of seawater sample. 15.0 dm cube silver nitrate solution is needed to reach the endpoint. Okay, so first question. If you were asked to draw the label setup, okay? If you're asked to draw the label setup, can you label those chemicals? Like this, right? The basic content is here. So can you fill in where you may find which stuff from Manhei? Which one is found in burette? Which one is found in conical flask? Manhei. Silver nitrate on top, seawater in conical flask. Yes, that's right. So you may see the word this time. It titrate against water. So it is not titrate against. Can you see that? It's titrate against. It's active voice. Titrate against. So seawater is in the bottom. So 25.0 cm cube of seawater. And on top of it, it is the silver nitrate solution, 0.500 molar silver nitrate. And finally, we'll use 15.0 cm cube. I just copied it down first. We've got this, okay? And any indicator is needed. Any indicator is needed. 袁天佑，袁天佑，袁天佑, are you here? Yeah, no need. Okay, so what would be expected observation? So if you add that to, now whether or not it's not just a memorizing but the understanding as well. So seawater, indeed we have to get the chloride ion, right? We are having silver ion and chloride ion react together. So the main reaction we are considering is silver ion and chloride ion to form silver chloride, which is in form of white PPT. White powdery substances is formed. But how about approaching endpoint? Or even what I mean is beyond the endpoint, beyond the equivalence point. So you may find it's still white PPT, right? It is quite difficult to tell that is the stop of the reaction. Okay, so that's why I need to add, yes, that's right. So you may find potassium chromate. So potassium chromate, I need this. I need chromate ions. which is in form of a yellow solution. Once I add this, so what will happen? It will form a compound called Ag2CrO4 solid. It is in form of a red PPT. Okay, so the whole procedure will be this. First of all, silver ion will react with chloride ion first. We'll react with chloride ion first to form silver chloride. So I give you the first drop here, first drop. So they will have some milky solution, right? Some milk, the solution becomes milky. But the indicator has been added, so the solution is very strange. It is whole solution is clear yellow, but once sulfur nitrate is added to it, there may be some cloudiness. Okay, can you imagine the case? And then you have to further add, so you may know the chloride ion will drop in concentration. Okay, so we have, but more white PPT will be formed. The solution become more cloudy, but the solution is still yellow. And we wait for some time until all chloride ion has been reacted. Okay, so any slight excess of silver ion will react with chromates to form silver chromate, which is in form of red PPT. Okay, which is when we are take a look on the, let me show you something about the graph. The graph, it is on this part. Okay, so you may see it on the, now you may see it on here. You are having so many different types of that. This is Morse method. Can you see that? Morse method. This is a type of precipitation titration. We focus on the solution, the color of the solution. This is on here, right? So this is, I've got 3 stages. So this is the before endpoint. We will have this, and this one, it is exactly as endpoint. While for this, it is beyond endpoint. So you may find the observation, it is harder to observe than before. Okay, so because you are dealing with something turbid, you're going to deal with something cloudy. That are you going to observe it as a brick red PPT? Yeah. But in practical sense, we will not describe as it as the observation, okay? Because if you observe it really at the far right one, it's much beyond the equivalence point. What we are looking for is the middle one. Okay, what we are looking for is the middle one. Can you see that? Is the middle one, where we have got a trace of brick red PPT of silver chromate, and together with many AgCl here. So which means that we are looking for the PPT, the white PPT turns a little bit pink. Can you get my point? We are now in practical sense looking for some pink powdery form, and you have to stop. But in your exam, while you write it down as the endpoint color change, you still need to write it as a brick red precipitate is formed. It is rather tricky. Can you get my point? So in your exam, please still write it as a brick red PPT. So the observation is that we have got the brick red PPT form, but in practical sense, it's a mixing of the two to form some pink. Can you get what I mean? Okay, so this is what I would like to remind all of you. Now, take a look on the calculations part. Because of that, of the given 2 equations, you may know what you're going to have. And which equations requires calculations? Just the first one. Okay, you just need the first one to do the calculations. The second one, no need. First one is a main reaction, while number two is the indicator reaction. It tells you when all high chloride ion has been reacted. Can you get my point? So I would like to find people for help. Yep. We can't see the screen. Sorry, I cannot open it, right? I just share it again here. Can you see that? You just focus on number one, equation one. Equation two, no need to do calculations. Yeah, thank you. Now, so I would like to invite some people here, to tell me the calculations part, the molarity of chloride ion in the seawater sample. I've said before, the observation is we have got brick red precipitate is formed. Okay, so for A part, the calculations of molarity of chloride ions. So first, you need to use which equation? As I said before, the highlighter one. So everything starts from this equation. Okay, so you are going to write down the equation and use this to tell the mole calculations. Are you here? Yep, just continue. So you may see the steps. 15 now. Take a look on the accuracy actually. So you may see suffix 15.00, 0.500. So you may see the suffix here. And then, yeah, so the answer is 7.50, yeah, times 10 to the power -3 mole. Yeah, that's right. So, but you are going to find out the molarity of chloride ion, right? So what is the number of moles of chloride ion? So it's 1:1 mole ratio. So which is equal. Okay. So if you want to save some steps, you may write down something like this: number of moles of chloride ions is equal to number of sulfur ions, and then you do the calculations. Okay. But our final task is molarity of chloride ion. So what should we do next? Molarity. The unit for molarity is mole per dm cube. So you know the calculations involve a division. Okay, division. What over what? Yep. How come you're so lazy? Yes, right. Is rather confusing because you just write as this, right? You may for the markers you may easily get it wrong. Mole per dm cube, which is in line with what we are thinking, right? So the I just want to know chloride ion the volume, right? Chloride ion, where chloride ion, yeah, this is in seawater, okay? So it is 25.0 times 10 to the power minus 3. Okay, you get my point, which is equal to 0.300 mole per dm cube. So for this questions is an easy start. The reason behind is that the equation tells you sulfur ion and chloride ion, they react in 1:1 mole ratio. Okay, can you get my point? So we will proceed to question B part, 4B. Any questions so far? Now, after 5 seconds, we will go to B. Any questions? All right. So if you have no questions, thank you, ladies and gentlemen. So you may come to B part. So as said before, B part, equivalent concentration of sodium chloride in mole per dm in a seawater sample. Okay. I would like to ask Chen Junhei. How to calculate this? Chen Junhei?
係攞佢個計到 chloride ion 之後，嗰個除翻乘翻嗰個，因為佢哋個 mole ratio 係1:1啊嘛，所以攞嗰個嚟乘翻
what is 1:1?
Na 比 Cl。
Na to Cl.
我上面揾咗 Cl， 所以應該係一樣。
Oh, you mean 1 mole of chloride, sodium chloride contains 1 mole of chloride ion. Do you mean that?
Yes.
Yeah. So chloride concentration of chloride ion, sodium chloride. So it is just exactly the same, 0.300 mole per dm cube. But I want to change the unit, right? Gram per dm cube. So what I'm going to do is to finally mark it as gram per dm cube. Here, first of all, what should be get rid of? I don't want mole. Okay, I don't want mole. So how? Per mole. I want gram.
gram 再除翻
Yes,
dm。
that's right. So gram per mole, what is that? It is indeed what is that actually? This is the molar mass of sodium chloride. Okay, so you may find it as 58.5. This 23.0 plus 55.5. Can you get my point? Only by having this, you may cross out those mole and turn the unit to gram per dm cube. So the answer is, what is the answer, Anakin?
好緊 cal。 17.55。
It's time to check the significant figures.
17.6。
Correct. This is in 3 significant figures. Okay, because of the molar mass of it being 3 sig figs, the molarity calculated is also in 3 sig figs. Questions? Easy start? Yeah. If so, we would go to question 1. Okay, after 10 seconds, I let you guys to read the questions again. So for that questions, we focus on, why do I say this one is an easy one? The calculations part is just involving the silver ion and chloride and react with 1:1 mole ratio. This one, okay, it's just 1:1 mole ratio, so they will not be so complicated, and also the coming out of the equations rather simple as well, and which is more tricky part is on changing the units from mole per dm cube to gram per dm cube. So you have to times the molar mass of the solute now, but not the chloride ion. Okay, remember, because we are going to have the solution of the chemicals of adding sodium chloride to it, but not just chloride ion. Okay, can you get my point? So which means that when you have a table salt, you want to sprinkle the table salt into the dish, you not only supply chloride ion but also silver ion add together, right? So once you get that concept in mind, you may know that you are going to times the molar mass of sodium chloride instead of chloride, as given in the equation. Okay. Any questions? Now, if not, we come to question 1. Now, question 1, it is a questions involving redox titration of permanganate ion. Okay, permanganate ion. So you may find permanganate here, right? Can you see that? So in order to find out the iron content, so it seems that you are going to have the 2 reactions. You are going to dissolve the iron tablets about 7.0 gram into the excess sulfuric acid. So I want to acidify the solution to make it the solution 250.0 cm cube. You extract only 1/10. Okay, you extract only 1/10. And you are going to titrate against. Can you see the word titrate against? So this is another direction of the what we will see in the conical flask. Okay, so the 25.0 cm cube solution is now at where? 老師話 tell me where you will find it, and where you will find the solution. 老師話 conical flask it is wet. What is the chemical? Is this KMnO4 or the iron 2 solution?
Oh, iron 2 solution.
Yep, iron 2 solution. About 1/10 portion is 25.0 cm cube of iron 2 solution. It is in the tablet, right? But on top, it is KMnO4. As I have made it acidified, I already exit here, right? I have made it acidified. The solution, the whole reactions will carry out in the acidic medium. And the molarity of this part, all of you please add 2 more 0. It is 0.0500 molar. 0.00500 molar of KMnO4 solution in order to do the calculations. Okay. 朱俊輝 any what is the indicator added? What is the indicator for this reaction? It seems that every time while you do titration, we need to add indicator. What is the indicator? KMNO4 itself. Somebody will say that, oh, KMNO4 itself is the indicator, but it is also a reactant, right? So while you tackle this type of questions, what you need to mention, right, is that you need not add indicator. No extra indicator is added. According to concept, Zhizhen's phase one is correct. KMNO4 itself is indicator. Why? But I cannot tell it is KMNO4 is indicator. Can you remember? Can you get my point? In the DSE exam. In the DSE exam, if I want to add indicator, which means something extra. Okay? While KMNO4, what is that? It indicates the endpoint of the reaction, but it's not indicator. Very philosophical, right? Very strange to understand. Why? Now, it is related to the ionic equation as well. Ionic equation. Lê Kiên Long, can you write down the ionic equation for the titration reaction? What is the chemical? Lê Kiên Long. Thinking. You may direct it to the label setup. What are the two ions on the left-hand side? Yeah, anyone who want to have a try? Yeah, okay. Great. Alan, you have made a very good study. You have got iron2 on here. And KMNO4, of course, is not carbodexamine, it's permanently iron. To form what? To form iron 3 and Mn2 plus. We are now proceeding to balance redox reaction. Okay? Like on, you should know you should know how to balance that. You ought to know how to balance that. Instead of telling me thinking. Okay, anyone who can show the oxidation number method. I just want to double check if you guys know how to do oxidation number method. Yep, everything starts from spotting the one which undergo oxidation and reduction respectively. Yeah. Okay. Now, different people will have different way of interpreting your plus sign and minus sign when you compare with this plus and minus. Can you get what I mean? According to number 9, yes, according to number 9, plus and minus means the one greater than 0 is smaller than 0. But once you write down plus or minus 1 and 5 here, that means increase and decrease in oxidation number. Can you get my point? So that may be somewhat confusing to the others. But anyway, at least I know you know how to balance that. Okay, so how would you have it? So just I would tell the as what Wen Jiwei has been stating here. Okay, we have the label to two. The first one, iron 2 to iron 3. Oxidation number +2 to oxidation number +3. We have got an increase in oxidation number unit is 1. Okay, we have got permanganate Mn and Mn2+. We have got oxidation number +7 in KMnO4 +2 in Mn2+, which experience a drop in oxidation number unit of 5. So as this number relates to the number of electrons, okay, it is in line with number of electrons. You have to balance the two half equation together, right? By getting rid of those electrons, you make it equal. So you may imagine that iron 2 to iron 3, that equation, they will have a 5 here, so as to cross out that 5 electrons for this half equation. Can you see that? So that's why you are going to times 5. Can you get my point? So how would you put this into the oxidation number method? We can skip the one on the right hand side. What we are going to do is to base on the oxidation number change to do that command. Can you get my point? So check it, is dropped by 1, increased by 5. LCM of that two numbers 5. So you are going to times 5 here, and remember to put a 5 here. And similarly, which means that you have got times 1 here and put it 1 here. But of course, the 1 here can be omitted while you write the true equation. 李健朗, do you understand? So what is next? What should be done next? Afterwards, you may see the half equation where I've got hydrogen, iron, and H2O, right? They must be there. They should be there, right? So how can we do it? Is to finish it. And you are going to find out we have got Fe, we have got 5. We have got Mn on this is 1. We have got that on both sides. What is missing? We've got oxygen here, right? On the left-hand side, we've got 4 oxygen. How about this? I need 4 oxygen. How? By adding 4 H2O. But all in a sudden, we have got H2O, I added H extra. We have got H hydrogen extra. So what I'm going to do is to add H hydrogen in extra such that we have got H hydrogen. And the elements part has been balanced. Think about the charge. Try to see if it can be balanced. So we have got +8, 5 times +2 is +10. We've got 1 minus, okay? So altogether the charge is +17. And how about this one? To do the same, 5 times +3 is +5, 15. And we have got +2 is also +17. The whole equation has been balanced. You got it? You know. Can you get what I'm now going to do? Okay. Instead of telling you it's just a 小小, you better proceed to the balance equation by yourself. There are so many examples, similar examples in the following questions. Okay, spend some time on it. And you use this to calculate the number of moles of iron 2 ions in a 25.0 cm³ of samples. So there should be 25.0. So because of the questions array, so I have just asked you guys to change it, right? 25.0 CMQ solution. So this is the one. The number of moles. Use this to proceed. Use this to proceed. So what is that? The number of moles of iron 2 ions. It is you have to use the data of permanganate ion to project. Okay, this is unknown on the conical flask. This is unknown. So this is known. What I'm going to do is to, from the known data, project it to unknown. So the number of moles of KMnO4 minus ions, how will you get that to? What you are going to times a factor. What is that? Are you here?
喺度諗緊。
係 times a factor. Now check the check the one on the equation. So what is meant by this? Iron 2 ions, we have got 5 portions. Okay, for iron 2. So permanganate, we've got 1 portion to react. So if you are going to have that 2 data, which one should be more?
MnO4 乘5。
Yes, that's right. This should be times 5. Can you get my point? So you have got 1 block such that we have got 5 blocks. Can you get my point? So as the saying goes, 除自己乘人哋啊嘛。Okay, we have got the number of moles of MnO4 minus 除自己 is alpha 1 times 5. Okay, can you get my point? So what you are going to add is to have 25.0 times 10 to the power minus 3 dm cube volume. The molarity, check 0.0500. Okay, so you are going to multiply by 0.0500 mole per dm cube times. I just want to make the steps longer. So let me double check. 0.005. 0.05 times permanganate. Is it 25.0? Double check. 11.00. So it is 11.1.00. Okay, times 10 to the power minus 3. So what will you get? It is, remember to times 5, okay? Remember to times 5. So what you're going to have? Permanganate ion. Now this is just permanganate ion concentration, number of moles. So what will you get?
2.75乘10嘅負4。
係啱啦，2.75乘10嘅負4。So it is 5.5 times 10 to the power 5 mole times 5 equals 2.75 times 10 to the power minus 4 mole. So that is the answer. Any questions? Any questions? Now, if not, Lei Tong, could you please tell me the percentage by mass of iron in a tablet? In the tablet. So, in the tablet, how many grams of tablet have been added? is 7.00 gram. Okay, you start from this. And then what's next? You are going to
將個 mole 乘翻嗰個 molar mass。
mole 乘翻 molar mass directly. That mole times molar mass, right? This 2.75 times 10 to the power 4 minus 4 and 10, and then times molar mass. Molar mass of what? Iron. Is it iron?
我再睇一睇個題目先。
Number of moles of iron in the tablet. It is 2.75 times 10 to the power 4 mole times. Now go back to these questions. The question, we have got the iron tablet. Okay, iron tablets. Altogether 7.00 gram tablet. Okay, and I dissolve it into the excess sulfuric acid and make up the solution. You have got that. This is volumetric flask of 250.0 cm cube. This is the water of the iron tablet solution. Okay, we have got the iron tablet plus excess sulfuric acid. So what's next is to put it into here, right? But it is just 25.0. So which means that I have got 1/10 of a portions to do the titration. So the number of moles of iron.
乘翻10咯。
Yes, the iron is it is not, it's just 1/10 only. You are going to times 10 first. Okay, iron number of tablets in tablet, because for that 7 gram of the tablet, I just analyzed 0.7 gram only, just 1/10. Okay, so which is equal to 2.75 times 10 to the power minus 3 mole. And then to use this to calculate the mass of iron in the tablet. So this time, because the focusing point is iron, so you can just directly do some mathematical treatment. Okay, check the unit first. Mass of iron is in gram. Is from mole. I don't want mole, and I want gram. Gram per mole. What is that? It is molar mass of iron. Okay, molar mass of iron is 55.8. So we will get it as 0.153 gram. So the percentage by mass of iron in a tablet, it is calculated as what? 0.135 gram of iron can be found in how many grams of tablet? 7.00 gram of tablet. Which is equal to what? A very low value. What is that? What's the answer?
2.19
2.19. Yes, percent. 2.19%. Okay. So the tricky point is on the word times 10 here. Do you know why? Because in the titration, we usually want to do the experiment shortly, okay? And at the same time, I don't want to spend too much chemical. So, and at the same time, we look for the consistency of data. I need at least 3 titration data, right? So that's why if you have got a tablet, we have to prepare a large bulk of solution. Very often you use 250.0 cm cube of a solution. But every time while you do the titration, you just extract 1/10 of a portion. So you use the pipette for help, 225.0 cm cube of pipette for help, and I do the titration. So from the titration data, is just they just reflect you 1/10 of the portions of the iron content inside that iron tablet. Okay, so remember, you are going to do the exercise by times 10. Do you understand? And what's next is to change the mole to gram. Okay, mole to gram, you use the unit for help. Please check. And finally, percentage by mass, you make it by percentage. You get to know what? You get to know that is the mass of the tablet. Not all tablet contains iron, right? We just only contain that mass, 0.153 gram of iron inside 7.0 gram of tablet. Is that clear? Okay. If everything is clear, we will come to question 2. 1E is more challenging. 1字位, if a vitamin C is also present in the tablet, do you expect the calculated value of mass of iron is larger than or lower than the true value? Explain your answer. Vitamin C. So which means that vitamin C also involved in the calculation, is it? If that is, why? Vitamin C.
Wait, overestimated as vitamin C also can be oxidized.
Can be oxidized. So why? Because vitamin C is an do you know in the fruits, it is a type of supplement tablet, right? So
Yes.
very often on the market, we will label vitamin C as antioxidant, 抗氧化劑, you know it? So which is, what is that? It is a reducing agent. So as said before, as I said before, it can be oxidized, right? So it is also react with KMNO4, which is an oxidizing agent. Okay, can you get my point? Which is also react with oxidizing agent. Therefore, as a result, so what will happen is about the volume of KMNO4 used. There will be more than expected. Okay, they will have the volume of KMNO4 used in titration is more than expected. So remember the term more than expected. So which means that if you take a look on the questions above, so you may see this data is not just 11.0, it will be more. But you treat it as correct. Of course, this data will be more, and this data will be more. And what's next? This data will be more than expected, and this data will be more than expected, and this data will be more than expected, and finally, this data will be more than expected. Can you get my point? So that is the final conclusion. The calculated value is larger than expected. Okay? 其意思得 key terms or overestimation or the expected value. What is that? It is the actual value. Okay? Overestimation. If you want to say the term, this is overestimated. 高估 Indeed, it should be lower. It should be lower, but the data value is quite high. So we call it overestimated. Okay? Question 2. In a reaction to find out the concentration of hydrogen peroxide, you do the same thing, right? What's the ionic equation? Chen Weihou, what is the ionic equation? So again, you're going to find out this. And try it again. So you may find that this one, KMnO4 on top, which is 0.0600 molar. And the solution, which is hydrogen peroxide, is about 25.0 cm3. Okay? So ionic equation. Chen Weihou, are you here?
喺度諗
Yeah.
下。
又諗乜嘢啊？ So what are the chemicals involved?
佢係咪個 KMnO4 變咗 Mn2 plus 跟住
Mn2 plus. So for KMnO4, which ion will be responsible? This MnO4 minus. Okay. How about the other one?
H2O2 變咗咩咧？變 H2O 啊？變咗咩咧？
So it depends on how you understand the element which undergo oxidation or reduction. So I will give you a hint, okay? So Mn here will undergo what? Oxidation or reduction?
Oxidation。我等陣數下先，負8正7正唔係喎 reduction 嚟嘅。
It's not just chemistry 2 lesson, but also chemistry 1 students who make me have hypertension. I need to take pills after today's lesson. Oxidation number units, they will drop by 5. Okay, so we will have reduction. Oxidation. So H or O, they would have oxidation. Terence.
咁佢應該係冇咗 H 或者多咗 O 啦。
Anyone who can help? Yes, that is O. Yes, that is O. O undergo oxidation. That will be what will be formed. Increase in oxidation number. So what can it be? Yeah, it is oxygen. Oxygen. We have got 0 here. So we have got an increase in oxidation number unit by 1. Is it? It's not just 1 because we have got H2O2 and O2, right? So you are going to already multiply by 2 already. So it altogether we've got 2 O undergo oxidation. So we have got an LCM of what? Of 5 and 2. Can you see that? 5 and 2. So here comes 2 here in front of Mn, and 5, okay, here. Can you get my point? In order to balance the equation. Okay, so remember, Mn here got fixed, O here got fixed. So it is quite confusing, right, for you to see the O. So label that O here. That O has all been fixed. So leaving behind is what? Can you see another O? This is another O. This is that O will not undergo oxidation or reduction. So this O, this is the O to be balanced. Can you get my point? So it will all together we've got HO on the left hand side. So what you're going to do is to add H2O on the right hand side to balance that O. Can you see? And what's next is to get to know this. Something has been balanced. Mn and O has been balanced. Even that non-redox O has also been balanced. How about H? On the right hand side, we have got 16H. So do we need to add 16H on here? No, sorry, no. You are going to get rid of 5H2 here. So what should be added finally is just 6 hydrogen ions on the left hand side. It's a very tricky question. Okay. Somebody who waking up. How about B? Suggest the color change when the endpoint is reached. Again, B part for that one is just what is the color change? Very similar. Very similar to what for the previous question. So what is the color change? Thank you. What is the color change? What is the color change? Isn't it not here? Anyone who can help? Do you want to have a lunch? Purple to pale pink. God. The case is similar to question A. Can you see that for 1A, I didn't leave any answer here. The answer is the same as 2B. So what is the answer? Same answer. 雷同。
Colorless to pale pink.
Yes, the solution turns from colorless to pale pink. So pale pink, what is that pale pink actually? Samson, what is that pale pink? What is that pale pink?
嗰啲permanganate ion。
Okay, why is it still there?
你滴多咗嘛？
Yes, iron 2 has been reacting the permanganate ion. So whenever I have got purple solution here, so they will react with iron 2. So the solution here will remains, the purple solution will remain decolorized. Okay, but I don't know whether or not the iron 2 concentration it is pale green, right? So but it will change a little bit yellow. But all in a sudden, while all iron 2 ions has all been reacted, okay, all been reacted, what will happen? So the slight excess of MnO4 added to it, they will no longer have any reducing agent that react to it. So what will happen? They will spread through the solution and make it the solution pale pink. Can you get my point? Similarly, the same case happen when you are going to do the same thing, right? Permanganate on top, hydrogen peroxide at the bottom. I add KMnO4 here, and they would soon react with by hydrogen peroxide. So the purple solution is decolorized as long as we have got hydrogen peroxide. But this amount will drop to the point that there will be no hydrogen peroxide. What will happen? Any slight excess of KMnO4 here, permanganate ion here, they would have no opponent to react with it, so they will spread through the solution and make it pink. The more the MnO4 minus added, the solution will turn to purple finally. Okay, because there's no more reaction. Can you get my point? The color of the solution, it will change its color from colorless to pale pink. So remember that pale pink is just a reflection of a very slight excess of MnO4 to indicate the reaction has come to an end. C. Calculate the molarity of hydrogen peroxide solution. Calculate the molarity of hydrogen peroxide solution. So you may have that mole ratio to consider, right? So this time, hydrogen peroxide will have got 5 mole react with 2 mole of H2O2. So what we are going to do is to find out this number of moles of hydrogen peroxide first, okay? Of H2O2 and number of moles of permanganate. What is the mole ratio? What is the mole ratio? Use the same concept, 2 blocks, 5 blocks, 2 blocks, right? So how I need to multiply a pattern to make it equal. So what is that? 11號. Yes, that's right. Okay. Can you get my point? So don't tell me one. I just want to use some simpler tricks in order to speed up the thinking of this vector. So the way to solve is to drawing blocks, please. Drawing 5 blocks, 2 blocks, and I'm sure you can answer it. Do you find it easier? Na M5/2 times MnO4 minus. MnO4 minus, so you get the data. MnO4 minus 0.0600 molar, and you spend about 15.0. So you need to use that two data. Okay, 0.0600 molar times volume. It is 15.00 times 10 to the power minus 3 dm cube. So what will we get? What will we get? What is the answer? 陳浩
撳一撳先，等陣。
And later on, I get this data, and it helps you to solve. Why? Because I have got these data and then to be put on here as well, and you may change it. So the answer is mole. So this is the mole, and then we've got the M cube. 2.25 times 10 to the power minus 3. Yes, that's right. So what is the answer? 2.25 times 10 to the power minus 3 mole over dm cube. What is the volume of hydrogen peroxide to be used? 25.0. Okay, so this is 25.0 times 10 to the power minus 3. So what is the answer? So we come to mole per dm cube for molarity of H2O2. 0. Come out again. Hurry up. 0.
等陣，再撳一下先。0.09
Specific, please.
0.0900
Okay, 3 specific. So 0.09 mole per dm cube. Okay. Questions? Now, sorry to say that we need to have a later lunch. Sorry. So we have come to question 3. For question 3, they are in order to determine the concentration of vitamin C in lemon juice. This time I use iodine to have a titrate against. So you may see the solution first of all is now diluted to 250 cm cube solution and use 25.00 cm cube of diluted solution to do the titration against iodine, and I use 15.00 make it 0.0, okay, cm cube of a standard iodine solution. So just write this diagram here, right? Can you make that help? The diluted solution is found here. The diluted lemon juice. So the diluted lemon juice contains vitamin C. So on top of it, it is what? This is aqueous iodine. The aqueous iodine. So you may find 0.0200 mole per dm cube of iodine. Okay, so finally we will use 15.00 cm cube of this iodine to have a complete reaction. So what will happen if I am going to add iodine into the solution? Now just imagine the case, right? I add iodine into the solution. They will react with vitamin C. So the iodine solution originally is brown. The brown solution becomes what? Becomes colorless, right? Becomes colorless. So what is the end point of this titration? So if I insist of doing so, right, we would do at the moment until we have got slight excess of iodine that put into it and then spread through the solution, right? Just like what you think as permanganate, right? But once I have thought so, the endpoint color is not so easily observable. Why? Because the iodine, slight excess iodine already is of very, very small amount. But once I spread through the solution, it is become more dilute. So the solutions, they will turn to pale yellow, while the color is not so obvious. It's not a significant observable change. Okay, it's not that significant change. So that's why we need to add something to it. Yes, that's right. I need to add some chemicals to it to indicate even a slight presence of iodine's form. It will give you a very intense color. What is that? Add what? Iodine. Starch. Yes, that's right. But remember, if you add starch, it seems like cooking recipe book, right? Starch at room temperature and pressure, it is in powdery form. It is in solid form. So remember to write it as starch solution to tell. It's not just starch. I must tell you the fact that powdery starch, okay, and you spray into the iodine will not turn to that blue-black complex so easily. So what you're going to do is to dissolve starch into water. You know that starch being a polysaccharide is not so water soluble. You have to heat solution for some time and let the starch get dissolved in the solution, such that the starch solution can be used to indicate the presence of iodine. So that is a practical sense. So add the starch solution as an indicator. First of all, 1 mark. 2 mark here, right? Then second point, it is to tell when the solution, okay, changes its color from what to what. Originally, it is colorless, okay? But I don't know. In reality, the lemon juice very often it is with food coloring. I don't know whether or not the lemon juice is really yellow or colorless. I don't know. Okay, but anyway, you write down colors first. Okay, to blue black. I really don't know. I really don't know whether or not the lemon juice is colors. I don't know. So blue black, there is the indication of M point has been reached. Okay, is that clear? So here comes part B and part C finally. Given that the number of moles of iodine, wow, quite nice, is equal to the number of moles of vitamin C. Wow, great. Because no equation is given, and you need not memorize the whole equation. So they will give you that information to have an easier life for you. So you are going to calculate the number of moles of vitamin C present in the 10.0 cm cube of a lemon juice. Remember, 10 cm cube of a lemon juice, which means in the original solution. Okay, is that original solution is 10.0 cm cube. So better you have make it to 250 cm cube and get 1/10 portion for dilution. So if you use this data, any data about the permanganate of iodine, it is related to this only, but not this, but not 10.0 cm cube. Remember that, okay? Remember that. So you need to do the data treatment. So by copying those information above, the number of moles of vitamin C in 25.00 cm cube diluted solution. So it is equal to the number of moles of iodine reacted in the titration, in one titration. That statement, I just copy it down, right, from the question. And because I see the word iodine, so check the data about iodine, okay? Iodine, what you get? 0.200 mole per dm cube for iodine, 15.00 cm cube. So this is the data. So 0.0200 mole per dm cube for iodine molarity times volume. It is 15.00 times 10 to the power minus 3 dm cube for iodine. So what we will get is about the number of moles of vitamin C. It is also equal to 3.00 times 10 to the power minus 4. Now, but remember, this is just the 1/10 portions that you may get. It's 25.0 cm cube. right? Can you see that? It is just these. It's just this one. It's just this one. So, but the chemical that we have added is 1/10, right? 1/10 portions. While that 25 cm cube will define the number of moles, can totally reflect this. This is equal number of moles of vitamin C here. So don't worry about this data. Okay, you need not consider the 10.00 cm cube. That data, you may get rid of this. Don't worry. Okay, but you need to know that relationship first. So what's next on that calculations is what? Is to multiply by 10. It is therefore the number of moles of vitamin C in 10.00 cm cube of lemon juice. So it is the original lemon juice, okay, without dilution. But this is diluted, okay, on the top, which is equal to 3.00 times 10 to the power minus 4 mole times 10. Times 10, it is the crucial point here, times 10. Which tells you you just extract 1/10 portions for that for analysis. So here comes the data, 3.00 times 10 to the power minus 3 per mole. Okay, so this is the part B. Last part, calculate the concentration of vitamin C in the lemon juice, but green gram per dm cube. How? I need to change a little bit, right? I need to find out what? I need to find out the mass, gram per dm cube. So dm cube I know is 10.00 cm cube, right? And gram, you need to find it first. Mass of vitamin C in 10.00 cm cube of the lemon juice, which is equal to 3.00 times 10 to the power minus 3 mole times something. You're going to make it gram first, okay? Gram, I need it. I don't want mole. So what is that? You put this. Okay, you put this. This is the molar mass of vitamin C. And what you can get is the mass, 0.528 gram. Okay, 0.528 gram. And I use this data for the calculation of concentration of vitamin C in the lemon juice. So you know the data should be gram per dm cube. Okay, gram per dm cube. So what's this? So this is, so what is that? We have got gram, we've got dm cube. No, this dm cube on here. dm cube, dm cube, dm cube. Okay, so what is that solution? It is 0.528 gram over 10.00 times 10 to the power minus 3. Remember, 10.0 cm cube. So what we get, this is 52.8. Okay, by doing so, we have nearly come to an end. So as I have told you, the way to do the calculations, I've said before, in your calculations part, you need to what? You need to get to know the two way. One is redox titration. The other one is precipitation titration. And which one will appear more? Which one will appear more? This is redox titration, because you may find they will have a greater variety of the questions. Okay, you may see it is involving KMNO4 minus KMNO4. It involves I2. Okay, no need to mention we have got one more case for iodine titration. I missed out one more case on here. Okay, so you may find the colorless from colorless to blue black. You may have one more occasion of having the titration. I would like to stress it once again. that you may have. This time is only not on here. We've got iodine in situ here. Okay. So rapidly produce iodine in situ, and the one here I would have thiosulfate solution. Okay, thiosulfate solution. We've got a standard solution of thiosulfate. So for this case, we are going to add indicator at the later stage. Okay, because iodine will react with star solution. So for this very special case, which is you are going to wait until the solution changes from brown to yellow. You are going to add a few drops of starch solution. Okay, so you are going to put this, and all in a sudden you are going to tell the endpoint is you are going to check for what? The decolorization. The decolorization of the purple solution, of the blue-black solution. Okay, so that is more complicated. So that's why if you want to study it better, as said before, you have got two concepts in paper 1 very solid. The one is Mokel, the other one is redox reactions. Is that clear? Okay, so I've talked too much because we have got 15 minutes far left behind. Okay, so sorry about that, but I do think by having this video, it will help you better understand. And because of this, we have got 2 videos. I will upload this to the YouTube instead. For those who want to have a replay, you may go to the YouTube channel and see it later. Okay. Once a reminder, tomorrow we will have a quiz on the other 2 chapters of Industrial Chem. Okay. See you guys. Bye-bye.